Hello everyone. Welcome to our fourth C5W webinar series, which is a series that we started a couple of months ago. And our plan is to have like one session a month where we kind of meet and then we talk about our experience or invite a guest and they can share their stories, what they are working on, all related to DFIR. The plan is one a month, but based on maybe availability and the speakers who we will be inviting to join these sessions, we might have more than once a month. So currently, I would say mark your calendars. It's going to be the first Wednesday every month. That's when our session will be done. So mark your calendars. We will send notifications, social media, like announcements and all of that. My name is Ali Hadi, and I'm the co-founder of Cyber5W. I'm also the digital forensics program director and the research director at Champlain College. With me is
Hello everyone, Mariam Khadir. I'm also an assistant professor at Champlain College. So today we're covering Windows investigation, right?
yep.
So we have a case which involved two devices. We have a Windows, we have a Linux machine, but today we are just focusing in the Windows artifact. So where can we find the case?
So good question. So if you go to our website and then if you go to the academy, I want to explain two things. Now, one, if you want to do this online, like let's say you want to play everything that we're going to be doing, but in like a virtual environment, then what you can do is you can again go to Academy Virtual Labs. It will bring you over here. And then over here, if you go down, you need to sign in. I'll show you in a little bit. If you go to internal investigation, so if you go to internal investigation, you can see this is the minimum you will need to pay if you want to do like you want to get access to a virtual machine and be able to use it. But what we are planning on doing, so that's if you want the virtual machine and to do everything online. But if you want to just kind of like access the data set and you like probably don't want to pay, which is completely fine, you can just go to Academy and then courses, and then if you go down to our, what is it? Case studies, you should be able to find it over here. It will be added over here. Just again, remember, it's going to be called internal investigation, and you will be able to find it over here. Once you go there, so let's say this is the one, you will see that there will be a link to where you can download the data set. Again, you don't need to pay if you don't want to, but if you want to kind of, let's say, play with us or use our environment, then this is what you will need to do. Otherwise, you can just download the data set. Now, I also wanted to show you if we log in, this is when I logged in my account, and if I go to internal investigation, then you'll find like that. So if I resume, you can find the description about the case, what are the required tasks, and then the scope of work, the data set. Again, it's over here, but we will have it also available for download for free, so don't worry about that. But again, this is how you will see it on here. This is how you'll start your virtual machine if you're planning on doing that. If you like purchase the or let's say, yeah, purchase access to the course and then you want to increase, let's say, the credits, you can do this, and this explains everything. Now, these are the tasks, by the way, that you need to do, and it's also kind of like uh, giving you a couple of questions and then looking on to answering them. This is an important thing which we will talk about in a little bit, but again, let's go back to the case that we have and talk about that, and then we'll talk about the verification and why this is also something that is important and we really want to kind of explain again. So if we go to the description, we have a victim who was kind of phished. Their system was compromised. They got fooled by a phishing attack. So the attacker gained access to their system and they were able to kind of like execute commands on their system, capture screenshots and etc. It is an internal investigation because the suspect is another employee working at the same environment, so they both work together, and the employee who works in the IT department actually fished or kind of fooled the employee that is in another department into installing like a something, and then they gained access to their system. So this case description, again, you can download the case from here, etc. So let's go ahead and just, these are the required tasks, by the way. How did the threat actor gain access to the system? We want to know that. What persistent mechanisms were used? What did the threat actor do? How did the threat actor know the victim's team viewer? Kind of like we added this question just to kind of do some investigations around team viewer and all of that, and whether team viewer was used or not used, and how was it used. So just to add like a flavor to this case, and like something not that we kind of, let's say, find on all of our cases. And then, did the threat actor use team viewer to maintain access to the system? Again, just to add a lot of different ideas to the investigation.
What is the data set for the case?
So the data set we have here is two systems. One is a Windows system, Windows 10 system, and then the other one is a Kali system, which was used by the suspect.
Okay.
So in today's webinar, what we will be doing, we will just go over the Windows part, and then we'll leave the Linux system for another session. So we'll try to cover as much as we can in today's session, and then whatever we have for Linux, we'll do that in another case. And also, probably if we don't finish the Windows part today, we'll also add that to another session. So let's get started actually now. So one of the important things is with the verification is one of the important things that we see people kind of usually I would say do incorrectly is when you ask them to hash, or I would say verify the image, they will go and hash it, use it, like PowerShell or hash my files and all of those different tools available. But when we talk about like hashing, verifying the evidence, or an E01 on a Linux system, you can use like EW verify, EWF verify. I think that's the command, if I remember, my brain is working correctly. And then on Linux, on a Windows system, one of the like easy tools to do is using FTK Imager. But hashing the file directly is not the right way to do it. The right way is to use one of those tools and then hash the use it to verify the image, because E01 is like a container for your disk and volume. It's not a file that kind of like you just go directly and hash it and then say, oh, this is the hash and it matches or not. While you still can do that, by the way, but that's not the, like in my opinion, and I think Professor, you agree with me that it's not the right way of hashing, because what's the point of then when we acquire the image and the metadata gets stored in the image itself?
Yeah, this is the problem that many people like have. E01 is a container that has the image with other metadata. So when you hash the E01, you hash everything. You hash the image with the metadata. So what happens if you use a forensic tool like FTK Imager, FTK knows that E01 is a container, so it will be able to go to the image and hash the image only for you. So our image is, where is it downloaded?
Okay, so let's just quickly go and kind of show what we are talking about. So if we go to FTK Imager and then we add the evidence, so we can add the image file, and the file we have it here on our share, which is this one, and you download it and then finish. And now what we can do is verify drive. So this is how we will verify it. Now this will take some time. So while this is doing the verification, let's go ahead and now start our process, or our like investigation itself. First thing is, let's mount it using Arsenal Image Mounter, which in my opinion and I'm sure, Professor, you agree with me, that this is probably the best image mounting tool out there.
We have
So,
a question is, what is mounting?
so mounting is, think of it in a way that we have this image, and this image contains like a drive or a volume or whatever, and we want to attach it directly to our operating system so we can access the files and folders under it. So mounting is kind of a way to attach this external image, volume, whatever, to our system so we can directly access that.
Okay.
Okay, so let's continue now. We did this finish? Oh no, still working. So let's go ahead, and as you can see, I'm using a free version, which is still good, by the way, even though a lot of like the advanced features is not gonna be there, but still, even with the free version, it's still one of the best tools out there. So mount the disk image, and again, we'll just go to wherever our disk image is, the E01, and then open. And then I prefer to use the write temporary. So what this does is, if let's say we need to access a directory or a file which needs some modifications or needs some special permissions, then with this way, it will do all the modifications we need in order to access that file. Now, this will not kind of jeopardize our evidence, or because it's going to all be done in like a cached file or a temporary file. So don't worry about, oh, this is going to modify my forensic evidence. No, your forensic evidence will be forensically sound, nothing changed to that. It's just going to modify this to like a cached file. So over here, I'm going to specify alternate difference location, because I prefer to save it on the desktop, and then I want to delete this, especially, by the way, if you're going to do something and then stop, then probably use this. But if you're probably going to work on a case and then let's say you want to come back tomorrow and work on it again or later, and you've already done some work on it or modifications, then probably you don't need the delete the differencing file. But in my case, I'm going to do that. So okay, and it's telling me where do I want to store the diff file. So on the desktop, save. Now it's going to mount the disk for me, and as you can see, it mounted it to 3 different drive letters. So G, F, and H. So if we go to the F, we can see this is the main volume we want to do our investigation on. Now, definitely, you'll probably be doing some like checks, like let's say going in and checking what do we have there, like user 1, we have this user, etc. And you probably maybe even do like a scan using, let's say, an antivirus or whatever. Do you want to add something, Professor? All good? Okay, I thought we have a question. So we mounted that. Now what I'm going to do is to speed our work. I'm going to use KAPE. Let's put this aside. I'm going to use KAPE to acquire the evidence that we want to work on. So KAPE is a tool which has been developed by a DFIR researcher called Eric Zimmerman. And probably if you just put Eric Zimmerman in Google, and then put a space, and then like type space, and then you'll see tools comes up, just because of how famous Eric is, because of all the great tools that he has done, and he totally deserves that. So KAPE is really a great tool for acquiring evidence for so many different reasons. Today the session is not about KAPE, but we will cover as much as we can to make sure that if you want to use it, then you can, and how to use it. So first thing is we want to go and say use target options, because we want to target some files. So how do we do that, or what are the files that we want to kind of acquire? As you can see, Eric has already, and I think these are also based on files and templates that the community has also helped build. So over time it has evolved from being a tool that Eric did, but then also it's also being updated with different templates. I'll talk about those in a little bit. One thing I do want to mention is there are two options of CAPE. One is the one that starts with GCAPE, and then the other with just CAPE. Now the one with G is a GUI version, and then the CAPE is the CLI version. Now, probably at the beginning when you're first starting and then you just want to learn about CAPE, I would recommend the GUI version because it's really just point and click. And later on, once you kind of feel that you're more comfortable with using the tool and how to use it, then and also if you want to automate things, then probably move into the more command line thing. But I'm going to talk also about the command line in a little bit, so don't worry about that. Now, target source is where do we want to acquire our evidence from. So if we click on this, and then we saw our target is this volume because that's where we saw it got mapped to, this one. So we're going to select that. So this is our target. And then where do we want to store our evidence? So we already created on our D drive a directory called results. And then in the directory, we created two folders, one called targets and then the other one called modules. So I'm going to use targets and I'm going to use that to save all of the evidence that we are going to be acquiring. Now that's part one. Now, the other part is we can use these templates. So if I, for example, select this one, as you can see, this is telling you where is this located and the folder. So it's in compound, and also compound, by the way, is a template for probably like let's say a template of templates. Let me go quickly talk about this because I think it's important. So when we go to compound, and if we go to tools, CAPE, and targets, and then as you can see here, it says it's in the compound folder. So if we go to compound, and then we selected the sans triage, then this is the one. Now the extensions, as you can see, it's .tcape because target CAPE, that's the naming convention that Eric is using with this tool. And now if we open it with the Notepad++, we can see the author who created that, Mark Holman, and like the version, etc. Now, as you can see here, these are the targets that this is going to be targeting. Now, one of them is an antivirus, and then the category is antivirus, but then it's telling you the path is antivirus.tcape. So it's another tcape file. Let's go ahead and also open this. So if we go to back to targets, and then we go to antivirus, okay. Let me just double check. So antivirus, this is gonna be in our, because it's a compound file. So if we open this one, and then in here, what we can see is these are all the targets that, or these are all the AVs that this will pull from. So for example, let's say if we look at Bitdefender, there's a bitdefender.tcape. So let's go open bitdefender.tcape. So if we go back, then antivirus, because as you can see here, this is for the antivirus one. And this one is being developed or prepared by Andrew Rathbun. So again, lots of community members are creating these files. So if we go to Bitdefender and if we open that, we can see where is this being pulled from. So Bitdefender, the category antivirus, some the name, and then where is this evidence pulled from. So you can see this one, and this one, and it's also from here. It's using a file mask, so some regex, so that way if a file ends with .db or db-wall, it's gonna pull all of those files for you. Now I just want to also put a shout out to Andrew, because a lot of, by the way, these updates to these tools also are done by Andrew, and also he's, I think, the leading the DFIR Discord channel. So probably check out all the things that Andrew does. A lot of great work he's sharing with the community. So again, as you can see, each one of these is going to go pull a lot of different information. If we go, for example, I'm going to do just one more last time. One more example, compound logs. Let's go and see the compound logs just to see what's going to be in there. So if we go back to the compound, and then did I say compound or is it combined?
Yes.
I misread that, sorry. Combined logs, if we open it, then edit, we can see we have for Windows event logs, this is where it's going to be located. Event trace logs are going to be over here. Now again, this is a TKAPE file, so it means there is a lot of details in there. So if we go and pull that one, event logs, and if we go back to targets, logs, sorry, not target logs, we go to Windows, and then we go to event logs, this one, and we open it. We can see this is automatically going to be pulling the event logs for you. So if it's a Windows XP, this is where it's located. Windows 7 Plus, this is where it's located. Other log files, this is where, like, if we, and this is usually found when you do an upgrade from, let's say, a Windows XP to a newer version. You'll see your older Windows system is there, so probably it's also important to pull logs from it. So again, as you can see, just by using these templates, we don't need to go using like FTK Imager or whatever other tool you prefer to use and go and copy these files from those locations. We can just do one single click and then that's it. Now, this is on the acquisition side. Yes, Professor.
I just wanted to say like how happy students are when they see this, because what you teach them, like, go and take this file, extract this file. So they go manually to extract files, and when they see KAPE, they are so happy that it can do it automatically. You don't have to go folder by folder to extract the files.
Yeah, so we torture them by going one by one extracting that, and then later on we show them this, and they get super excited because now no one's gonna use our old methods anymore. And thanks to Eric again. Now, if we continue, let's say we have volume shadow copies. We did do a webinar on that. Probably it's our first webinar on volume shadow copies. So please go and check that one. We won't talk about that in here. And then the output, you can store this these results like in just have them as files pulled for you, excuse me, on in like a VHDX, VHD, or a zip file. So if you want to share them with your colleagues who are working with you on this investigation, you probably want to pack them in like this container. So it's really up to you. In our case today, we are not going to do that. Now, this is just to acquire the evidence. Now, if you want to see how KAPE is going to make your even processing these files, like now we acquired them, now we want to run tools to process them. Now what you do is you just go and use modules. So modules here, you can see if we use that, this is going to go and process the tool, it's going to go and process the files that we acquired. Now, as you can see here, the module source, if you don't like, if you are planning on using this, then by default, the tool will automatically go and pull this. But if you prefer to copy the path, you can also do that. But by default, this is not going to be required. You can leave it. The tool will automatically go here and process the files which were acquired from there. So that's part one. Part two, where do I want to store my results? So I go here, the module destination. And again, like we said, we have on our D drive results and then modules. We kind of just separated them, targets and modules, just for like understanding and making it easy for you to understand as well. And then select OK. So this is now going to do acquire from here and then process them and store the process data in here. Now, what we want to do is we also want to use Eric Zimmerman tools. So we're going to use the easy parsers. Now, there is one thing which I want to talk about today, and then we'll probably do another session for that when we talk about modules. So modules, if you go to the modules directory and then let's say you go to compound, and we can see the extension is .mkape. So we saw easy parser, and easy parser is a compound file, so we can see it's in compound. If we open it, again, it's like easy to understand as well. We can see these are like what this tool is going to be doing, and you can see the command line that needs to be used, etc. So all of this is found over here. Now, excuse me. One thing I do want to do is I want to also parse user assist files. So what I'm going to do is go to the bin directory, which is, by the way, where the binaries that are going to be used. So the binaries to be used are going to be in the bin directory. Okay. And then in here, I want to go to RECMD because we want to use the registry explorer kind of tool, which is to parse registry entries. And then we'll do again a session on, maybe another session on KAPE, but I want to use one of those batch examples. So if I go here, I need to create a file called DFIR. I think that's the name of the file, called DFIR batch. But what I'm going to do, because I'm interested in the user assist files, so I'm going to copy this file. I'm going to call it DFIR batch. And then I'm going to do this. Now let me open this file so you can see what is inside. Now, again, we'll talk about these batch files in another session, but for now, I will just quickly say it's a way to kind of filter out unneeded registry data, because, by the way, when you parse Windows registry, it's gonna give you a lot of information, and it's probably gonna and if you want to focus on something, and probably is gonna add a lot of more evidence to you, or let's say a lot of artifacts, so that way it might consume more time. So in this case, anyway, what we want to do is parse the user assist. Okay, so we'll show it in two ways: one using KAPE, but using a batch file. So all you need to do, again, what I did is copy this user assist and rename it to DFIR batch, because that's what KAPE is going to be using with RECMD. Now that's one. Two, I also here, let's say you want to use Hayabusa, because, or I don't know if that's the right way of pronouncing it. So Hayabusa, I forgot the A. So Hayabusa is a tool, it's a tool created by a Japanese group of researchers to parse Windows event logs based on Sigma rules and a lot of different also rules which are created. So we'll do another session about that. For now, if you want to use Hayabusa through KAPE, all you need to do is one, select it, okay? And if you want to see the details of it, like what do I need to do in order to be able to use it, double click here. It will pull this file for you, like the editor. And you can see it's telling you, one, go create a directory under modules bin. And that's exactly what I did. So if I go under bin, you can see we have, let me pull this here. We have a directory called Hayabusa. And then all you need to do is place the zip archive in there. So I unpacked everything in there. And then usually Hayabusa has like dash the the version of it. Just rename it to Hayabusa like this. So if it's using this naming convention, just rename it to this. Okay, and then you can delete everything else, and or leave everything else like this. So in order to use Hayabusa from KAPE, that's all you need to do. Okay, and probably, by the way, every single other tool that you can see in here, oh sorry, let me keep this, but remove the filter. Probably every other tool that you need to use, like Chainsaw, which is another great tool, you'll see how to configure it to be used with KAPE. So not complicated, and even because everything is kind of documented for you. So now that we selected Easy Parser, and we also selected Hayabusa, I'm going to use the output format to be, or the export format to be in a CSV format. So that way we can use our friend Timeline Explorer. And if everything is ready, I'm also going to ignore FTP warnings. I don't want those. Before I go and hit execute, I do want to mention one thing. So again, let's say you're still new to KAPE, you don't know how to use it. So now with this GUI, you learned how to use it, which is great. But moving forward, you want to use the CLI version, as you can see here, current command line. This is all you need, by the way, with no minus GUI, because this is the GUI. So this is all you need in order to do what? Use KAPE on the command line. So if later on you want to automate this, or you want to know how can I do the command line version, again, now as you can see, with those point and clicks that we did, this is showing you what has been done on the command line version. All good? No questions?
Good. No problem.
Okay. So let's hit execute and see what's going to happen. It's going to tell you, hey, we are going to flush these directories. So if we go back to like results, modules, and targets, make sure those are empty. Otherwise, if you have any data in there, this is going to delete them. So, okay, we want to do that. So this is now going to start the acquisition process, and then it will start the processing part in there. Let's go back, by the way, since we are waiting, to our FTK and see in here, we can see that we do have a match. So the MD5 hash, so this is the computed, so this is the hash value that got computed, and this is the hash value that was stored in the metadata that Professor Maryam was talking about. And we can see the verified result is a match. So this is the best way to verify an E01 file, whether it has been modified or changed or not, but not going and hashing the E01 file itself. I wouldn't do that. This is the proper way of doing it. Okay, and again, we've seen this multiple times in casework or with people doing our exams, etc. So this is how you should be doing it. So that's good. Our case is working properly. We don't need FTK anymore. Closing that. And we're just going to wait for the processing to start. While we are doing that, any questions?
So today we are going to focus maybe in the execution artifact, because the victim said that like he noticed some activity in the device after he ran a WinRAR executable.
Okay.
So we want to see what happened there. When did that executable run? If after it was run, did anything else change in the system?
Okay.
So first thing we are going to look at is prefetch, maybe.
Okay, we'll look at prefetch. Let's see what program execution artifacts we can find. So the victim said, like Maryam was saying, that once they downloaded WinRAR, some weird activity started to happen. So we will start like from there. Probably we'll look at, so we can use that as our pivot point and go from there, and then like look at all of the evidence and the details that we have. But still, we are just waiting for this to finish. So as you can see, it's processing. It's, by the way, very fast. So don't worry about that. It's really a very fast tool in acquiring and also processing things. So we can just wait a little bit for this to continue. So we'll focus on the prefetch files, program execution. We'll check the UserAssist. Let's also go over like Harlan Carvey's RegRipper, because it's another great tool to show the UserAssist, probably like there, or at least give an example of using it.
You can also use a SRUM.
And we can also, yeah, definitely we can also check some. Yep, that's true. So one thing is, while this is working, let's go ahead and get our RegRipper ready. So RegRipper is another kind of tool, which is one of probably the oldest tools out there doing registry parsing and forensic analysis or analysis on registry, Windows registry. And Harlan Carvey is the author of these tools, and he's also an author of many Windows forensic books. Actually, I did learn, I kind of like started a lot of my learning from Harlan's blog and books, so shout out to him and all of the great tools and books he wrote over the years. I would highly recommend you check them out. So if we go here and check RIP, by the way, which is the main tool, RegRipper. As you can see, by just running it by like that, you can see it tells you how to use the tool. So it's giving you a lot of great examples. So there is really no rocket science in what I'm going to do. I'm just going to use a tool to parse, let's say, the registry hive, which is the nt-user.dat. So I'm just waiting for this to finish. But before, let's go here and see if the results of the targets. Okay, so I do see that UserAssist, user1. So let's say I want to process this. What I can do now is say nt-user.dat, and then the plugin that I want to use is the UserAssist plugin. So if I do this, and then probably what I can do is redirect the output to, let's say, let's do the direct the output to result, not to results. Let's do UserAssist.txt. So if we do this, the device is not ready. Oh, sorry, it's not D. It's on my E drive. Yep. So E is where I can store. Let's see if this is done. Yeah. So this, by the way, KAPE was done, and I clicked enter. It just happened so fast, so you didn't see that, but it has been completed. So if I do this, you can see it parsed it, by the way. So if I don't add probably the redirect, if you want to just see it like this. So let's see if we do it. You can see this processed all of the user assist, but I did redirect it to a directory. So if I go back to here, we can see this is what user assist has pulled. The plugin has pulled from, excuse me, from the end user hive. Okay, so you can see the user used like team viewer, setup. We can see MS Paint and all of that, but it's a little bit in a different format. So this is what you can do with RegRipper, and like a lot of more than just this. But I just want to, while we had some time, just kind of go over this quickly. Now, if we go back to, we are done with this, so we don't need this anymore. We can close, but also probably before I close, I can save KAPE CLI. So probably, so this will pull it up for you next time. I'm going to close it now if you want to do that. Now, if we go back to our results, so go to modules, because that's where our results are, and go to program execution. And now if we get our timeline explorer, so let's open this, and then go to our, let's load the prefetch file output. So PECMD is for our prefetch file output. One is showing us the timeline of how these events like happened, okay, and one is showing us like just in general these events in here. Do I have a filter here? Clear grouping. Okay, yes, there was some filter here, by the way, and this is probably from our test we did before our session. So if we go here, we can see these are all the files that we have. Okay, these are prefetch files. And Professor, do you want to kind of give us a quick explanation on what prefetch files are?
Yeah, so prefetch file is it's a feature in Windows. Whenever you run an application, Windows try to find or locate all the files and libraries that are used by this application. So it's a nice feature to make launching the application faster. But for us, the nice thing is that we could know that an application was executed in the system. So using a prefetch, if there is a prefetch file for a specific application, I can say the user double-clicked in that application to run it. So here we can see the name of the application. We can see also the source this prefetch file was created, which is interesting artifact. It tells you the first time this application was running. You can see also the running count, how many times this application has been executed in the system. You can see the hash of the application, the size, the version, the last run. And the nice thing is that for Prefetch in Windows 8 and later version, you can see the last 8 times this application run in the system or it was executed in the system. And because like the suspect, not suspect, sorry, the victim said that WinRAR was the reason for all that, we came here to find, is there any record about WinRAR?
Okay, so what we can do is if WinRAR was used, then we should be able to find WinRAR in here. Now, what we are seeing here,
There is no prefetch.
there is
for
no
WinRAR.
prefetch file for WinRAR, which is kind of weird. Now, we do see one in consent.exe, which is kind of like briefly, I'm going to say this, an environment which gets created for CLI or let's say programs that run under like the CMD. So it's kind of like a container for them, probably. Think of it like that. So we can see this file is here, but if we go, sorry, to the end and look at files which have been loaded. So if we go to file that has been loaded, we can see here, and let's probably do this. Let me copy them because I don't like the way they are. Let's see if I can. Yeah, I think we can still see it here. It's just that I want to copy them for a reason. Let's do Notepad quickly.
So these are the files that are loaded for the consent application.
These are files exactly that got loaded when this consent.exe was used. So if we search for WinRAR, okay, in this, so in current document, we can see that we have WinRAR over here. So we see that WinRAR was executed from user1 downloads directory. So we can see, yes, WinRAR was
in the system,
was probably used on, but we don't find, or we didn't see WinRAR in our prefetch files, which is kind of like weird. Why is it not there? So if we also kind of like search over here, same thing. So WinRAR, there's nothing because in the timeline it's not there. So something has happened to WinRAR. So let's kind of, let's say, remove this and then also kind of like go scroll through it again. We know the case, and like definitely this is gonna be, let's say, in a normal investigation, is gonna take you some time to kind of go through it and not kind of, oh, this has happened and this is what happened and something like that. But it will definitely take you some time to go and like go through this and look at the results in there. But if we scroll here and like spend some time on what are the data that we can see in here or what programs have been used, we can see sdelete has been used. So sdelete has been used, and then probably sdelete was used to kind of delete the prefetch file. We have no idea yet, but we do know that the prefetch file was, WinRAR was used on the system because we saw it in the consent and that it was being loaded, and we saw there is an entry for that file in the system, right? So it has to be, we think it has been used. I also want to do another thing here, Windows Defender. I want to stop Windows Defender because let's go to that directory. So I want to stop it because I know if there's anything wrong in there, it's gonna go and probably delete it. So if I go to our F volume, which is where we mounted our evidence, and then users, and then user one, that's where we saw, and then downloads, we can see WinRAR is there. Okay, we can see WinRAR is there. Now, one thing probably you can do is either like, let's say, scan it with VirusTotal or whatever other tool, or if, let's say, you also have an offline sandbox, excuse me, you can probably use that to kind of investigate this. But depending on the nature of the case that you have, you might not always be willing to upload this like to a public sandbox, like let's say VirusTotal or any.run, etc. So it really depends on the nature of what the case, but maybe an offline sandbox, or maybe just kind of checking it out with someone who has some little bit of malware analysis skills or whatever. If you have them, then that's great. You can do it yourself. But we can see the exes there. We saw that there was a usage of consent and it loaded exe, but we don't see the executable in the prefetch file. So what should we probably do next, do you think?
So even if it's not in the prefetch, we can't say it didn't run in the system. There are like a lot of possibilities. So there are other artifacts we can check. But before that, I'm interested to see sdelete. Like when sdelete was run in the system, what did sdelete did? We can maybe see the files referenced by sdelete in the prefetch.
Okay, so let's check those. So this is sdelete, by the way. So if we go all the way to the end, because those are the loaded files, and then if we go here, and then probably if we look at this, we can see sdelete did work with all of
these files. So
yeah.
There is this executable t.exe.
This is also a weird one that seems it's in the temp directory. And it seems probably what it has been deleted. So if we go to Windows and then /temp, we probably won't see the T file in there because it has been deleted. Okay, so that file, the T file, was deleted. We don't know why or what is it, because it's removed. Like Mariam said, now the question was, or what was asked, did that exe get executed? We can do t.exe, and we can see we do have t.exe. Now, one thing, by the way, if you want to do these filters, probably what we can do is, let me go here to the executable, and over the time we will do a lot of other videos to kind of explain the capabilities of this. What you can do here is maybe just t.exe if you want to narrow down and select, let's say, just this one. You can do it like that. That's one way of doing it. But the other way, which really is one of the powerful things of like Timeline Explorer and like what Eric has in there, is we can do t equals, or not even equals, wait, we can say ends with t.exe. So if we do ends with t.exe, I'm going to do that begins with, sorry, because that way we can also, we can just probably, yep. So if we do begins with t.exe, we can see it's going to filter the results for me. Now, t.exe, has it been run? The answer is yes. When was the last run? We can see this was the last time this executable was run, but t.exe does not exist anymore where on this system. So let's go ahead now and look at another thing, which is,
I can't find anything in the prefetch. Where should I go next?
So we can check, let's check SRUM, and I also want to prove that this file was actually deleted.
Okay.
T.exe and also the WinRAR one. So let's check first SRUM. So if we go back to our KAPE results, and if we go to SRUM, and we can go to application usage. So if we go here, and also I want the network usage, and if we go here, so let's look at these two things. One, so SRUM is it's the system resource usage kind of monitoring. So every time our processes are being running, if I go here quickly, no, sorry, not this one. If I go to Task Manager, so when we go to Task Manager, and let's say we go to application history, so these programs, when they are running, they are consuming CPU time, network, so they are consuming resources of our system. So SRUM is kind of like a way of tracking that usage. Okay, so as you can see, Windows does a lot of tracking on applications that get used on the system. The goal of the system here is for user experience, but for an investigator, these are really useful to us for kind of our investigations. So let's search for WinRAR, probably like RAR. So WinRAR, yes, we can see it. It has been used. It has been used by user 1, and this is the SID for it. Let's see actually also t.exe. Can we see t.exe here? And probably let's do and filter, so just like we did previously. So begins with, yep, and then t.exe. We can see also t.exe has been used. Now let's go to network usage. We can see, and let's do a filter on the exe info probably quickly. So begins with, or actually let's do begins with when rar WinRAR, so we can see WinRAR, actually contains, I'm going to do here, WinRAR. So we can see WinRAR was used, okay? And what about, and t.exe, let's see that. And I would, that's not contains because it's going to pull a lot of, begins. Yeah, let's do begins. We can also see that one has been used in here probably. Okay, so we can prove that they were used, and I know we are running out of time, so let's go do two more things probably before we call and for today's session. Let's look at the results of our registry that we did, because we did UserAssist, yes, right? So let's pull that. And if we use UserAssist here, I'm gonna go and because it's pulled from the end user, so we can hide this column, and this is to show where it's being pulled from. I'm also gonna hide, or actually I'm gonna leave this and maybe group by, so that way let me see quickly. And UserAssist, yeah, let's group by these because we have two users. As you can see, we have our like user 1 and then default user, so we can now see the results of each one of them, but grouping them. So that's one. And then also we can see over here is, let's see if WinRAR was used. We can see WinRAR was actually used, so that's another proof that WinRAR was used. But why was there no prefetch file? Probably it was deleted. We don't have any proof yet, by the way, that the prefetch file was deleted, but again, we have a lot of evidence proving that WinRAR was actually being used.
This maybe confirm our suspicion about the application. Like,
yep, exactly. Why was it deleted? Yes, that's true. Because if this was a normal exe, then why would someone then just go and delete the prefetch file? Probably they were trying to hide their trace, but they didn't probably hide their trace in the best way possible.
And maybe this helps us in determining the timeline of investigation.
Yep.
So now, like the first time it was running, this is the first, like,
exactly,
around this time we start investigating other applications and what happened in the system.
Exactly. So we can use again that as a pivot point in our investigation. So probably we have that, and then look at all of the evidence that happened after. Probably also look at how did we end up with this file. But again, this is going to be a lot of great proof for us what happened actually after that. One final thing let's do today, and then we'll call it a day for now, is let's go to our file system, and let's go to our journal. I'm sure we'll need to do another session about like just NTFS journaling. But in the NTFS journaling here, we kind of group them by, oh, this is still using the name. Let's probably just clear this. Is this a journal? MFT? Yes. Yep, so we can see this is the journal, by the way, that we have on the, oh, wait. This is, by the way, based on the filter. So let me just delete that. Sorry about that. Again, this is based on our kind of pre-testing things. So what we can do now is we want to check which files were deleted. Like for example, we were interested in the prefetch files to prove it was deleted, right? So what we can do is go to the extension, and then in here say, excuse me, .pf, and select that. So now we are only listing prefetch files. Okay, we are only listing prefetch files. Let's look at the updates of prefetch files. So we'll see filter based on that, and we are interested in all of the files that were deleted in like the prefetch file. So if we go here and we say file deleted, so the let's say the reason that what happened is the delete. So and by the way, you can see this filter gets built. You can also write this, by the way, yourself. So if you go to the editor, you can write this yourself, and it's really not complicated. We'll do that in another session. We'll show how this can be done. It's not complicated, and it's very useful to do and use when you want to do filtering, because sometimes it's much easier to kind of just write them down and then copy and paste them rather than going and selecting them. So anyway, these are all the prefetch files that probably were deleted. We want to focus on WinRAR, right? We wanted to see whether WinRAR is one of them. And if we do a search now, we can see WinRAR was actually deleted. So we saw WinRAR was used. We saw we didn't see a prefetch file. We found it in lots of different locations, and we now also can see that WinRAR was actually what deleted. So all of our suspicion about or around WinRAR has been kind of proven. There's a lot of more work to be done, but for today and for the sake of the time that we have left, this is probably what we will end up with. Is there any questions that we can kind of answer quickly today, or are we good for today's session?
I think we're good for today, yes.
Okay, everyone. So just a reminder, hope this session was useful to you. Just a reminder, by the way, if you want to get to this case, go to the website, go to the academy. If you want to play online, go to virtual labs. When you go here and then go to, this is the case. So again, the fee here is if you want to use an online system, but if you don't, you just want to download it, then you can go to the academy.
And I just want to mention that all the tools we use today are free, so you don't have to have a subscription or anything.
Yep, that's exactly. We try to use a lot of the free tools just so that way it can really be done by anyone, anywhere, anytime, and not being tied to like a subscription that you need to go and pay. And nothing against commercial tools, lots of great developers behind it, and they are doing updates, and they are also worth what you have to pay for. But if I want to do forensics and I can't afford that, can I still do my job? The answer is yes, we can. So if you go here under case studies, you will find, hopefully by the end of today, that case over here, and then you can download those the data set to use in your investigation. Again, this is just part one. This is, by the way, a bigger case that we can't cover all of it today. There is also another part of it, which is the Linux part, which we'll also do in another session, focusing just on Linux investigations. But that's it for today. Speaking with you was Ali Hadi, and
Maria Fadel, thank you.
Thank you all, and I hope you enjoy the rest of your day. See you next month in our next webinar.